Hi everybody, Grandad here again. And what am I up to today? Well, today I'm going to do a little bit more science with you. Now, it's a beautiful sunny day here in Oswestry, Shropshire, England. And the experiments which I'm going to do today, a little bit of chemistry, is a little bit tricky. Partly because I'm outside and it's not too windy, but it's very sunny, which means that some of the experiments I'm going to do might not be very clear. They'd be better done inside, but I haven't got a laboratory inside where I can work very well. And so we'll have to do the best we can. Now today we're dealing with gases. Now gases are very tricky, and the one gas in particular which I want to talk about and hopefully demonstrate is oxygen. Now oxygen, as you know, everybody needs oxygen to breathe. But the air we breathe isn't entirely made up of oxygen. There's lots of different gases that makes up the oxygen, molecules of gas, because everything's in molecules, and gas molecules are a little bit scarce in the atmosphere. There's a lot more other gases. I can't remember offhand. I can't name all the gases that are in the air that we breathe all around us. We can't see them, obviously, but we know that they're there. And with a few experiments we can sort of prove it. Now in front of me here I've got two little experiments going, and they're two little dishes. I hope you can see them because the light is not terribly good. But in this one I've got a blue liquid, and in this one I've got a yellow liquid. Now the colour doesn't matter. The colour is only there so that hopefully it'll show up. Now in this blue liquid, which I prepared a couple of days ago, it's just ordinary tap water, just ordinary water, and with a little bit of food colouring in to make it blue. But what I did, inside this is a test tube upside down in this liquid. Now what I've done, I wet the inside of that test tube and I sprinkled inside some iron filings. And during the course of the last couple of days, this has been sitting in this water here, and that iron filings have been going rusty. Now you'd hardly believe it, but rust needs oxygen in order to work. Things don't rust if there's no oxygen there. So what's happened inside that test tube, the oxygen has been used up by the iron filings going rusty, and as a result it's dragged, or sucked if you like, all the oxygen out of that tube. Now to replace the space inside that tube, it's sucked up this blue liquid from the dish below. Now I don't know how easy you're going to be able to see it. I'm holding it in the shade here, but if I bring it across to the camera, hopefully you can see that the blue liquid has been drawn up inside the test tube, showing that the oxygen has been used up by the rusting of that iron filings. Now surprisingly enough, the experiment has actually stopped now because all the oxygen that was in that tube has been used up. And as you can see, it's only a tiny bit, a little tiny bit at the bottom. In fact, it's about 1/5 of the atmosphere that was inside that test tube was actually oxygen. The rest of it was other gases, hydrogen, nitrogen, ozone, all sorts of things. So that shows the air we breathe is only about 5% oxygen. Now the other experiment I've got here, which I hope demonstrates the same thing, is a little candle floating on this liquid of just ordinary water with a little bit of colorant in. And if I light this, if I can get it to light, if I can light this candle, it burns there quite happily as long as there's no wind. Now if I cover it with this other little dish, I hope you're in the right position to see this. If I cover it with this little dish and cut out any more oxygen from going into there, we should see, now I don't suppose you can see it on camera, but I can see that that flame is still burning. And gradually as it burns, it's using up the oxygen that's inside that container. Now already it's burnt all the oxygen. Now it's not so easy to see on this one, but the same thing has happened I hope you can see that. It hasn't done it quite as much. We'll try that again because it's quite easy to do. I'll take the lid off and I'll light it up again. If I get that little flame burning, you can see that it burns quite happily in the air, and it floats in that dish quite nicely, which is good. Now I'm going to cover it again, and hopefully it'll keep burning long enough to burn out all the oxygen. Now while it's burning out the oxygen, obviously the liquid rises up inside that container, replacing the oxygen that's been burnt. Now again, I don't know whether you can see it, but the level of the liquid has risen up. I could see the candle actually rising as the air was being used up. And again, there's not much oxygen inside that container. It didn't burn for very long, and it's risen up now, and I don't know whether you can see that, but the liquid in the jar is clearly higher than the surrounding liquid. And it even looks a little bit darker because it's concentrated. Now that again shows you that there's only about 5% of oxygen in the air. Now, while all this has been going on, you probably noticed that I've got another little experiment going on here. Now I'll explain this experiment because it's been running for about half an hour. And what I've got is some water, and what I've put into it is a little bit of bicarbonate of soda in the water, and 2 test tubes. Now the test tubes were full of the liquid. I turned them upside down and filled them with the liquid before I set up this little experiment. Now at the bottom of each test tube I've got a little wire and a little bit of carbon rod. Now that's connected to a battery, and I've had it connected here. Now again, you're not going to be able to see this on camera very good, but as these two, this current goes through the electrodes, I'm doing a little bit of electrochemistry here. The air inside these tubes, one is filled with oxygen, hopefully, and the other one is filled up with another gas, which is a strange gas called hydrogen. So I've used this electrolysis system to fill up these 2 test tubes, and I've got a cork here, and what I'm going to try and do is pull out my electrodes very carefully, lift up the test tubes, and hopefully cork them off with this cork to keep the gas inside. It's a bit tricky, but as I say, when you're dealing with gases, it is tricky. That cork is the wrong size cork, really. Now in theory, inside there should be filled with oxygen. Now somewhere here, which I seem to have lost, no, it's gone, disappeared. Hang on a minute, I'll get another one. Right, I'm back again. I lost my little spill. Now apart from a little bit of water in there, this test tube should be filled with oxygen. Now then, if I light this little spill I've got, get it burning, and then once I've got it burning quite nicely, I'm going to blow it out, but it'll still be red hot. Now I'm going to quickly put it inside this test tube. Now unfortunately that hasn't done what I hoped it would. I hoped the spill would reignite, but it didn't work, unfortunately. Now I don't know whether the oxygen escaped and didn't show it, but I wasn't able to show that there was oxygen in that tube. Now that was a pity, because it does work. It's just that for some reason it didn't work for me just then. Now, in the other tube, we should have trapped a little bit of hydrogen. So hopefully, if this has worked, I should have trapped in this test tube a little bit of hydrogen. Now hydrogen, I don't know whether you know it, but hydrogen goes off with a bang. Now hopefully if I knock this cork out with my little lighter close at hand, hold my thumb over the end, get the lighter going, and hold it by the neck of this tube. Did you hear the pop? Maybe you didn't, but I did. It popped, so that showed that there was hydrogen inside that test tube. Now, you may have noticed, if you're looking, that I've got another little beaker over here with something else going on. Now inside this beaker, I've got some hydrogen peroxide, which I've got here in a little bottle, and also some sterilizing fluid, which is like Milton sterilizing fluid, and this is just to remember what it's called, sodium hypochlorite. Now when you mix those two together, they make these bubbles. Now those bubbles are actually oxygen. So although that first little experiment with getting oxygen didn't work, let's see if this one will. Now what I'm going to do, I'm going to light my candle here, and I'm going to pull off this little cardboard lid that I've put on this jug. And hopefully when I put my torch inside the oxygen, it should burn a lot brighter. Let's see if it does. Get my burner going. And there we go. Don't know whether you can see that, but that flame, although you couldn't see it when it was outside the jar, now it's inside the jar, it's burning really brightly. So that shows that I was producing, and when I pull it out, it disappears. When I put it in, there it is. You can see it burns quite brightly inside that oxygen-filled area. So that sort of worked, I suppose. And it showed you that there was oxygen inside that test tube. Now, as I say, it's not easy doing experiments with gases because they disappear before you have a chance to do anything with them. But I'm hoping I've demonstrated in this little experiment. It's not been a very long video. I can't see how long it's been going. About 12 minutes. So it is not a very long video. I'm hoping to do some more videos on gases. Maybe we can show you some carbon dioxide or something like that that's a heavy gas and demonstrate how that works. Incidentally, I never told you what these were on about. These, as my dad always used to say, there's more than one way to skin a cat. Now, I don't know how many cats he skinned and how many ways he knew of doing it. But that's what he used to say. There's always more than one way of skinning a cat. Now, like with this experiments, I've shown there's different ways of showing the same thing. And I rigged up a couple of experiments here showing different ways of making oxygen. Now, in this test tube here, I've got some sodium bisulfate. Put a little bit of sodium bisulfate and some zinc off an old battery. The casing of a battery, I got some zinc. And I put it in here and it's been bubbling away. Now the gas that comes off there is also hydrogen, I believe. So if we loosen this cork and light our little spill, put my finger on the end again, if I can get this to light, we may get a pop out of this. And it did pop. I don't know whether you saw it, but it did. I heard it. Maybe you didn't, but that's another way of using chemicals to produce hydrogen. And the other one, it's a slightly different experiment, but I was producing a gas in here and I'm not sure what it was, but they say that if it works right, it burns with a coloured flame. Now let's just see if it does. Get my flame going. As you see, it's not very bright and not very colourful, but if I put it next to this test tube, you can see it burns quite yellow. So obviously there's a gas coming out of there which is quite bright and burns yellow. Now that wasn't very spectacular and it's got a bit hot there, but what I thought I'd do today is some people might say, oh, Grandad doesn't do very exciting experiments. he never does anything terribly exciting, and you know, they are not very well impressed. Now you might have noticed in the background here I've got a little anvil set up, or a little vise, and I've got a little bit of something inside this foil here, this little tin foil. Now I put some crystals inside here. Now I call this white lightning. That isn't the proper name of it, but it's white crystals. It looks like snow, and it's white crystals, and I've put it inside this little bit of tin foil. Now I'm going to put it on my anvil. Now if you're watching this video and you think you know what these white crystals are inside this little packet, put a little comment in the comments telling me what you think these little white crystals are. Now I'm not going to tell you what they are, because if I tell you what they are and showed you how I made them, I'd probably get taken off YouTube, and I don't want that to happen. So I'm not going to show you how to make them or tell you what they are. But if you can tell me what you think they are, it might be interesting. So and as usual, before I go, I'll just ask you to subscribe to my videos and put a like up if you think they're interesting, and share it with your friends, and hopefully I can get a few more followers on my channel. But I'll finish this little video now by saying, as usual, bye-bye now, and I'll just give my little packet here, if you can identify it, a little tap and see what happens. Woohoo! Well, did you like that one? That was a little bit more exciting. It certainly made my ears ring. I don't know about yours. So what do you think that was? Put a little comment if you think you know. Bye-bye now. Bye-bye.